today we are starting a new unit, excuse me, or new chapter, okay? We're going to be working on chapter 3, and we're actually going to skip the first thing in there because we're going to do it all today, okay? So chapter 3.2, and we're going to work on something called slope, okay? Slope. So before we work on slope, I guess I'm having trouble speaking today. Before we work on slope, I want to go over some kind of graphing basics. Okay, so we will be graphing lines. Okay, graphing basics. Okay, some real basic things. Okay, first one is, can you label the axis for me? Does anyone know what is an axis? Does anyone know what that means? What's the axis? Right, there is an x-axis, Andy. What other letter is there for an axis? And a y-axis. Does anyone know which one is which? Which is the side to side? Is that the x or the y? This is the x-axis. Okay, so let's label these. So the side to side one is the x-axis. That means the up and down one is the y. Okay, so that's the x-axis. That's the y-axis. Right? Does anyone know what this point is called? This point has a special name. Does anyone know what that point is called? Starts with an O. Okay, this is actually called the origin. Okay, the origin. So that's a special point. That means that's where everything starts, basically. Okay, origin is like the beginning. So this is basically the origin is at 0, 0. Okay, so this would be at point 0, 0 if we were graphing it, or if we were labeling it, excuse me. So, other things that you need to know are types of slope. Types of slope. Okay, types of slope. There are 4 different types of slope. So I'm going to want you to draw 4 different XY axes. 4 different XY axes. Okay, I'm going to show you the 4 different types of slope. Oops, sorry. One looks like this. One looks like that. There's one that's like this. And one that looks like that. So basically 4 different kinds of lines that I drew you here. Okay. First off, does anyone know what is slope? Does anyone know what is slope? Can anyone tell me, what do you think slope is? When we talk about slope, we're saying the slope of a line. What do you think the word slope means, though? Say it again. The bend? Kind of, yeah. Yes, ma'am. The steepness, exactly, okay? So, slope is the steepness, okay? So basically, this is, would you say that this is increasing in steepness or decreasing? Increasing. So this is something that we would call positive slope, okay? This is positive slope. What kind of slope do you think this is? Negative. This would be negative slope. Right, so the way I want you to think of this is slope is kind of like, do any of you ride a skateboard? Does anybody skateboard? Okay. Does anybody snowboard?
On my belly. Well, skateboard on my belly.
Oh, okay. Does anyone snowboard or ski? Okay. Slope, I think of as like the mountain slopes. Okay, like, if you've ever heard someone that's a little bit older say, oh, we're going to go to the slopes for the weekend, okay? You guys would probably never say that, but slopes is like the mountains, okay? So this one, I want you to think of like a little person. You're going to love my little drawing here, okay? Little person, okay? If you're having to walk uphill, how much effort are you having to put in? A lot or a little? A lot. That is positive slope, okay? If you're walking downhill, how much effort are you putting in? Like, not much at all, right? You're putting in, like, negative effort because it's so easy. You could almost, like, fall down this hill. What if you were just walking flat? This is my lovely little drawing. What if you're just walking flat? Do you think that's like, it's like zero slope, okay? You're just walking flat, okay? It's like not more than normal, not less than normal, okay? This is what we would call zero slope, okay, or flat. Okay, that's zero slope or no slope. Okay, zero slope, or we could say no slope. And what about this one? Do you think, like, how do you walk like this? Like up a wall? Can you walk up a wall? No, not unless you're Spider-Man, and none of you are Spider-Man. Okay? Okay, let me take this back, because sometimes this can be a little bit confusing. This is not about you anymore. Can Mrs. Coon walk up the wall? No. Okay? Because some of you may have superhero powers that I just don't know about. So let's just make this about me, okay? This is not possible. Okay, so this is something we would call not possible or undefined slope. Okay, if it's a 0 with a slash through it, that's called undefined slope. Okay, or you could say no slope. Now, you got to do it with your feet. Can't walk up the wall with your arms, with your hands.
I got this. What up?
Thank you. We'll check that out later. Okay, yep, nope, feet. Straight up, like this. Yep. Yep. Perpendicular or parallel to the floor, thank you. Okay, so this is undefined. You could see it written like this, undefined, or you could say no slope, okay? Because it is not possible, basically, okay? I want you to understand there's a really big difference between zero slope and no slope, okay? No slope means not possible. Zero slope means flat. Okay, so make sure that, or try to not get the two confused with each other. Okay, so again, what did we say slope is? Slope is steepness. Okay. Or does anyone have another word for steepness?
Down.
Does anyone have another word for slope? How would you describe slope? Like if, yes. No, you don't know?
Like a hill.
Like a hill, okay, but what if I asked you to describe slope to like your little brother or sister?
I would tell them it's a hill. It's not a hill, but it's like a hill.
Okay, so it's like steepness. Okay, are we okay with steepness?
Yeah.
Okay. Technically, slope is equal to, okay, technically, slope is equal to how much you go up divided by how much you go over. I'm going to show you in just a sec. So, technically slope, and we're going to talk about positive slope, okay, has to do with how much you move up and then how much you move over. So if I was going to measure something, I could measure the slope between this point and this point. And the way you do it is you figure out how much you move up divided by how much you move over. Okay? Is there a better word, do you think, that we could use for up and down? Think about it like with a hot air balloon. What do you call it when a balloon goes straight up?
Flying. Accelerate.
Rise. Okay, what I'm looking for is rise divided by, this is what we call run. Okay? So how far you move up divided by how far you move over. Now, sometimes it can also be negative. Okay, so rise could be up or down, technically. Okay, run, we are always going to measure the run in to the right. Okay, we always move to the right, just like reading a book. Okay, you always move to the right. So you could move up or down, but when we're figuring out run, you always move to the right. Okay, so can anyone tell me if this was on a graph, the up and down, is that the Y's or the X's on a graph? The Y's, okay? So rise over run is also the change in Y divided by the change in X, okay? This will become very important in a little bit when we start putting some numbers on here. Okay, so change in y divided by the change in x. So now we actually got to calculate some slope. Okay, so now I actually want you to calculate some slope. So if I ask you to, so is everyone good up to here? We good to there? Can I move the page? I'm not gonna mess anyone up. Okay. So for example number 1. Okay, example number 1. If I ask you to find the slope, okay, so give me just a second. So find the slope. Okay, find the slope, and I'm gonna draw you a picture because I can. Okay, let's say that I have a skate ramp, and I build a skate ramp like this. Okay, it just basically looks like a triangle. Okay, and I build a skate ramp, and let's say that it is 3 feet up and down, and it is, let's say, I don't know, 12 feet long. And I ask you to find the slope. Oops, sorry, you can't quite see that. And we're going to say that this is a skate ramp. Okay, whether or not you can tell it's a skate ramp, it is. I'm not a good artist. So, find the slope. So what we want to figure out is how much it rise or fall divided by the run. So when you figure this out, how much is the rise or fall? And remember, this line or this skate ramp, you're going down, right? So how much do you rise or fall here? If you're starting from this point up here, we're just going to make this a point to get to here. How much do you rise or fall? Are you rising or falling? Falling. So if you're falling, what do you think the number should be? Positive or negative? Negative. So negative 3, and we don't have to put the labels on it, divided by how much do you think you move to go from the left to the right? 12 feet. Now, what do you think I can do here? Reduce. So how can you reduce that? What goes into both of them? 3, so this would become what? Negative 1 over 4. That is the slope of my ramp. Okay? So all you're really doing is figuring out what is the rise over the run. And sometimes if it's negative, that just means or if you're falling, if you're going down, all you do is just make it negative. Okay? Next thing I'm going to ask you to do is, again, for number 2, find the slope. So this one, I want you to find the slope of the line. Okay, find the slope of the line. So for this one, I'm going to give you a graph. Okay, and we're going to say 1, 2, 3, 4, 5. So put 5 spaces on each axis. And let's say I go from, so I'm going to draw a line for you. Sorry, give me just a second here. So I want it to go from here to there. So find the slope of that line. Find the slope of that line. Any ideas how you do that? What do you think you're going to do? First thing you need to do is label the points. Okay, so first thing I want you to do is label the points. And whenever we're asking you to find the slope of a line, they are going to give you like definite points here. Okay, so there's going to be a point there and a point there. So you don't have to figure out like where are the exact points. Also, I promise you that on these in your book, see how they're on grids? So it's a little bit easier. Okay, I apologize that I don't have a grid behind this, but we're going to do the best we can. So for this one, what you have to do is, and what are we going to find for the slope? What do I have to count? How much it rises over how much it runs, basically. So to rise, I need to figure out how much I go up And for run, it's how much I go over. So let's figure out, because we're always going from the left to the right, how much do I rise to get from up here to up here? So basically I want to figure out how many steps do I go up. Count. 1, 2, 3. So you just count, literally, and you can count with your pencil or your finger. So up 1, 2, 3. Divided by how many do I go over? 1, 2, 3, 4, 5. And you're just counting. Okay, so if we're finding out the slope of a line, you count how far you go up divided by how far you go over. Okay, so next one I want you to try is I'm going to do the same thing. Okay, I want you to, again, we're going to find the rise over run. Okay, we're going to find the rise over run. And for number 3, same thing. Okay, what if I ask you to, again, find the slope of, I'm going to draw another graph. Let's put 5 points out, or 5 spaces. And for this one, we're going to go through here, through, sorry, I'm thinking, obviously, and here. Okay, and connect those. So I go through right here and right here for sure. Again, I want to figure out the rise over the run. Rise over run. So, what do you know about my rise here? It's higher. This is, what kind of slope would this have, this line? A negative slope, right? Because you're moving down. It's like you're walking down. Okay, so your effort level, or your slope, is negative. So we automatically know that we're going to be going down. So make sure it's negative. Then, to get from this point to this point, and we're always going from the left to the right, how far would you have to walk down? How many steps would you have to take down? If you count down 1, 2, 3, it's supposed to be 3, okay? So negative 3 over, how far do you move over? Over 1, 2, 3, 4, 5, 6. So negative 3 over 6. Do you think I'm done here?
No.
Why? You can reduce it, okay? So even though technically this one isn't reduced, are these the only points that it absolutely goes through? No. You could also label it goes through 0, 0, right? So if you want to, okay, this reduces to be what? Negative 1 over 2. What would happen if I counted the slope to go from this point to 0, 0? Let's try that one, okay? Here, if I counted to get from here to 0, 0, how far would I move? How far would I rise? What's my rise to get from here to here? How far do you move? Step down how many? 2. And how far would you move over? How many steps would you take over? I'd move step down 2, and then how far do I step over? 1, 2, 3, 4. What does that reduce to? Negative 1/2. So do you notice that it really doesn't matter which 2 points you pick? Any points on the same line, okay? Every line has the same slope no matter which points you pick on it, okay? So as long as you can figure out exactly where those things are, you can pick any points, okay? Absolutely any points, and the slope will be the same. Even if you went from this one to this one, okay? These are closer together. So here, if you checked that, to get from there to there, you would step down 1 and over 2. So between any 2 points on any line, the slope will be the same. Okay, that's kind of important. So between any 2 points, on a line, slope will be the same. Okay, between any 2 points on a line, slope is the same. Okay, kind of important that you understand that. So between any 2 points on a line, the slope is the same. Okay, next thing I'm going to do is we are going to try to find, slopes from a table. Okay, so given the table, find the slope. Okay, given the table, find the slope. So we're on example number 4. So given the table, find the slope. And for this one, I'm going to give you what's called an XY table. Okay, so you're just going to have to draw this. It's not going to be, like super crazy. Okay, so something like this one, you would see, sorry, I just lost my points. Okay, so this one, you might see an XY table written like this. Okay, and your X values are -6, -2, +2, +6, and the Y values are -2, -1, 0, and 1. So you might see an XY table written like this, and it'll be in like perfect boxes and stuff, but we're just going to do our best here. So go ahead and draw that, and then we're going to learn how to find the slope. Are we all done drawing our table? I want you guys to be able to pay attention, so I don't want you worrying about drawing it while we're still going. So, given the table, find the slope. Now, a couple different ways you could do this, right? If we wanted to, I could put every single point here onto a graph and then I could count. But that's not incredibly effective, especially once you get like some bigger numbers like these. So if you remember at the beginning of our notes, when we were talking about slope, okay? Remember we decided how much you go up divided by how much you go over probably isn't the best way to explain it, so we decided that it was more simple to say rise over run. Now, if I don't have a picture, I can't really count the rise over run. So what you have to do is you're going to use this value. Okay, so change in y divided by change in x. So I'm going to give you the formula here. Okay, slope is equal to, okay, we're going to write y2 minus y1, so the change or the difference in y's, divided by x2 minus x1. So go ahead and just write that down to start with. Okay, y2 minus y1 divided by x2 minus x1. Now I'm going to show you what this means in just a second here. Basically what we have in this table are points. Okay, can someone tell me one of the points in this table? And a point, remember, is always like an x coordinate and a y coordinate. Tell me one of the points in this table. Just read me one of them. 2, 0, exactly. So that's one of them. Okay, 2, 0. So if you wrote these out as points, the first one would be -6, -2. This one is -2, -1, 2, 0, and 6, 1. Those are all the points in the table. They're just written in a different format. Okay? I personally think it's a lot easier when it's written in this format. Okay? Because the tables can get a little confusing sometimes. Okay? So here, what you actually have to do is you need to label these. Okay? First thing you need to know is I only need 2 points. So how many points did they give me here? 4. I really only need 2 of them. Okay, so you just pick any 2. Doesn't really matter. I'm going to pick these 2, mainly because they don't have any negative numbers. Okay, and I don't want to deal with negative numbers if I don't have to. So what we're going to do is we're going to label these. In the 2, 0, which is the x part and which is the y part? 2 is the x, okay? 0 is the y. So I'm going to label this as x, and I'm going to label 0 as y. So that's 1 point. My other point, 6, 1, which is the x part, which is the y part? 6 is the x, 1 is the y. Now the only problem here is I have xy and xy. All you have to do is I'm going to label these as x number 1, basically. So x1, and you just put like a little 1 like subscript. Okay, if you were typing, this would be subscript. And this is your y number 1. It really doesn't matter which point you say is the first point and which one is the second point, as long as you're consistent. So if this is your x1, that has to be your y1. Then this one would be your x2 and y2. So label your 2 points, x1, y1, x2, y2. Then we're going to plug into this equation. So if I plug into this equation, you're going to get, I want you to put it in parentheses. Okay, so we're going to leave this equation just like this. And we're going to plug things in here. So here, what goes in this spot? What's my y2 number? What's my y2 number? 1 minus, what's my y1 number? 0. Okay? You guys are making a really common mistake here. We have to remember that we're always doing y's over x's. Okay? It's really difficult, or it's really easy for people to think that they should do the x's first, but we're not doing the x's first. We have to do the y's first. What would be your x2 number? 6 minus, what's your x1 number? 2. Then we just have to simplify. So what is 1 minus 0? 1. Over, what's 6 minus 2? 4. So guess what? This is the slope of that line. Okay? If we drew all of this, if we labeled it all and counted, how do you get from one point to the next? That's it. Okay? And you could pick any 2 points. Okay? It would have worked with this one and this one. This one and this one. Any 2 points. Does not matter. Okay? Let's try another one. For number 5. Okay? Same thing. I'm going to give you something in a table, and I would like you to find it. Okay? I want you to find the slope. Okay? Find slope given. Okay? If I tell you the table is showing the number of gallons of paint that someone used to paint the rooms in her house. Okay? What you're going to do is you're going to write, so this is gallons and rooms. Okay, so you might see an XY table written like this. She used 2 gallons of paint to paint 3 rooms, 4 gallons of paint to paint 6 rooms, 6 to paint 9 rooms, and 8 to paint 12 rooms. Sorry, I made this way too big. So gallons of paint and rooms. So if I wanted you to find the slope, do any of these, do you see X or Y written anywhere here? No. What you always do is we always make the first thing X and we make the second thing Y. Okay, that's just always the way it goes. Okay, we always make the first thing X and the second thing Y. Then I want you to label it, and we're going to pick 2 points. Okay, so 1 point is 2, 3, then 4, 6, 6, 9, and 8, 12. Which 2 points do you think that you would like to pick? You want to pick 4, 6, and 6, 9? Why? Just because? Okay. You usually want to pick the ones, if there's negatives, I would not pick the negatives just because they make more confusion. And if there's all positives like this, I would usually pick the ones that are the smallest. Okay. You're just going to have to do, like, not as much math if you pick the smaller points. Okay. So I'm going to pick these 2 points right here. So I'm just going to put a box around them. Okay, these are fine to pick, but they're just bigger numbers, and usually you don't want to deal with bigger numbers if you don't have to. Then I want to label these. Okay, so what would I label 2 and 3? I know that this is the x part, and this is the y part, but what am I forgetting? The ones. Okay, so x1, y1, and the second point is going to be x2 and y2. Now, you will need to memorize the slope equation. So, the slope equation, slope is equal to what? y2 minus y1 divided by x2 minus x1. And I do have a poster that I will put up for you to help you remember that. But you will need to memorize that equation. Okay, you are going to have to memorize that equation. So, if we're going to plug things in here, okay, and I want you to plug in from here. What would you plug in for y2? What do you plug in for y2? 6 minus, what do you plug in for y1? 3 over, what's x2? 4 minus 2. Then, can you simplify that? 6 minus 3 is what? 3 over 4 minus 2 is 2. Can that be reduced anymore? Sorry, couldn't even see it. Can't be reduced anymore? That's your answer. Okay, that is the slope of your line. Okay, that would be the slope of your line. Okay, and the last kind of problems that you're going to have are going to be just like this. And again, it's going to ask you to find the slope. Whenever we're dealing with slope, it's always slope of a line. Okay, so find slope of the line. Okay, and this one is going to say find the slope of the line that passes through the points. Okay, and I'm going to give you 2 different points. So find the slope of the line that passes through the points. Okay, and if I give you, let me give you, sorry, I totally just lost my train of thought. Let's do that passes through the points. Say J is -7, -4. And point K is -3, -2. Find the slope of the line that passes through those 2 points. Now, this can get a little confusing because now we've added in 2 more letters. Okay? Do the J and the K really matter? No. Okay? Those are just naming the 2 points. So if you had a picture, they're just naming their point. So they're saying like the first one is point J and the second one is point K. All you need to worry about is labeling them. Okay, so what would you label -7 as? x1. -3 is x2. -4 is your y1. -2 is your y2. So label these as x1, y1, x2, y2. Then plug into that slope formula. Okay, and the slope formula is y2 minus y1 over x2 minus x1. So if we plug things in here, what is your y2? -2 minus, what's your y1? -4. Those negatives will cancel each other out. Okay, so this negative in the middle does not count for the negative here. So sometimes it's better if you put them in parentheses. Okay, you don't have to, but sometimes it's better if you put things in parentheses when you're first plugging them in. Okay, what's your x2? What's your x2 value? -3. x2, -3, minus what's your x1? -7. Then, when you get rid of these parentheses, what happens? This becomes -2, negative turns into what? +4, over negative 3 plus 7. Then we can actually do the math here. So what's negative 2 plus 4? What's negative 2 plus 4? Positive 2 over what's negative 3 plus 7?
I'm lost.
Negative negative turns to positive.
Did it multiply?
Nope. They were adding things together. Okay, so this should be 4. That reduces to 1 over 2. So let me show you guys one more time how I did that. Okay? You have to look at these points. Okay? When you're plugging in, Drew, stop. When you're plugging in, okay, when these get plugged in, I want you to be doing it like this. Okay? Put in your equation just like this. Then plug in your numbers. So here, when you're plugging in, what's y2? Negative 2 minus what's y1? Negative 4. See how I have two negatives there? That's what they turned into positive. Then x2 we said was negative 3 minus x1 was negative 7. These negatives cancel each other out. So negative, negative, they turn to positive. Same thing happens on the bottom. Then you actually combine them together. Okay, so negative 2, positive 4 gave us 2. Negative 3 and positive 7 gave us 4. And then those reduced to be 1/2. Better? Yes. In just a minute. Okay, so you guys are going to be working on, in your book, you're going to be working on page 185. You are doing numbers. Page 185. We're going to do numbers. Sorry, I just lost my place. 1 through 8. Okay, you're going to be doing numbers 1 through 8. As well as, let's go 15 through 1 through 8 and 15 through, sorry, I just lost my point, 24. I'm sorry, 15 through 31. Changed my mind. 1 through 8 and 15 to 31. 1 through 8, 15 to 31, yes. Okay, you guys have work to be doing. I know that was kind of long, but you need to get used to these. Okay, get to it, please.